Ladies and gentlemen, today we are discussing indices. Now, last class we treated quadratic rates, and that was what we did. So I said we did indices and logarithm. So this is the part one, which is indices. Now, what do my indices? Indices is probably the plural for something called the index, which is referred to as power. It is also known as exponent. So if I should tell you a base A has an is raised to an exponent or has an exponent of n, it simply means power, or better say it simply means any of these two. So indices is the plural form of the index. So I can say, oh, it is raised to the index of 2. Aha, that's the point. So now here I have my base. Here I have my base. So that's about the 10 indices. That's what is understood by the 10 indices. And another thing is that there are laws governing indices. Now, these laws are what we apply in order to solve initial equations, initial questions. So without those laws, you can't solve any indices question. It is a must, they are applied. Yes. So now let's just move to laws of indices. I'd like you to follow me diligently. Okay, now laws of indices. The first law is the multiplication law. The multiplication law. The multiplication law. Now, this law is simply stating that when a number of equal bases are being combined with multiplier with a multiplication with different powers, then the powers are being added. That's when we have a raised power n plus n. So one of the bases is raised to the power, the sum is raised to the sum of the powers. So that's just the point. So for instance, if I'm given 2 raised to the power 5 times 2 raised to the power 2, it is, okay, let me use 3 here. Now it is equals to, since we have the equal base, then I add up the powers, which is equal to 2 raised to the power 5. So now, if I'm to do it individually, 2 raised to the power 3 is 2 times 2 times 2. 2 raised to the power 2 is 2 times 2, which is 2 times 2 is 4 times 2, 8 times 2, 16 times 2, 32. Right? If I'm to do this too, it is as well equals to this. Because 2, this is equals to 2 times 2 times 2 in 5 places. 1, 2, 3, 4, 5, which is as well equal to this 1, 2, 3, 4, 5. So they are equal already. So that's the law. So whenever you have two numbers of equal bases with different power, even be it with the same powers, what do? You add up, you pick a base raised to the sum of the powers. You pick a base raised to the sum of the powers. So that is a raised by n times a raised by n, or a raised by m times a raised by m. This is equal to a raised by m plus n. This is also equal to a raised by m plus n, which is equal to a raised by 2m. Still the same thing, whichever way you place it. It's still what? The same thing. So the second one now is what called the division law. The division law, now in the case of multiplication, now in the case of division, what if they are being combined with a division? In this case, what do? We pick a base and we subtract the powers. And we subtract the powers. That's what we do here. So even though I have equal bases 2 divided by a raised by m, what do? It is also equal to m. We also subtract the powers. So for instance, as me we have 2 raised by 3 divided by 2 raised by 2 is equal to 2 raised by 3 minus 2, which is equal to 2 raised by 1, also equals to 2. So equals to 2, right? Let's do it individually. I have 2 raised by 3 all over 2 raised by 2, which is equal to 2 times 2 times 2 all over 2 times 2. 2 cancel 2 cancel 2. What is left is 2 all over 1, which is equal to 2. Same answer. So meaning the law is valid. So that's just that about division. In the case of multiplication, you add up the powers to the base of just one number to a single base. Same thing here. one of the bases to power raised to the subtraction of the powers. So that's just what is about. Now the next one is double index law. Is double index law. Now, as the name implies, double index. I've said index means power. So double power law simply means there are two powers involved in this kind of law. So it simply means if you are given a raised power m times n, you can see that we have two powers, though it can be more than two. It can be triple indexed, but the point is just, or let me say multiple index law. Let me put it that way then. So I have multiple. It can be up to 3, 4, 5 depending on the question. So now the law is just that whichever how long it is, what you are doing is to just multiply the what powers, provided it is combined with what bracket m times n, which is equal to a raised power m n. So if I'm given a raised power m raised by m into brackets p q r is still the same thing. A raised by m times p times q times r. Even if it is like this, q same thing I do, which is equal to a raised by m p q r. It's still the same thing. So that's just the point about multiple index law. So okay, now the fourth one is what I call the zero index law. The zero index law, as the name implies, is zero power. That is, the power is zero. So that's where we find out anything raised by 0 equals to 1. How is it equals to 1? Anything minus the same thing makes up 0. As I am Peter minus Peter, you automatically cancel each other, which will be liberating what? 0. So I can see a raised by m minus m. M minus m is still equal to 0. So applying the that I didn't finish this because I knew I'm still going to do it. So I'll be having a raised by m divided by a raised by m is equal to a raised by m over a raised by m. A raised by m here 1, a raised by m 1. I'm having 1 over 1, which is equal to 1. So that is the reason why a raised by 0 equals to 1. That is anything raised by 0 except 0, where a is not equal to 0. So provided a is not equal to 0, n raised by 0 is still what? 0. It's still 1 rather. Provided a is not equal to 0. So that's it. That's about the zero index law. So the next one is fifth one is negative index law. Now the negative index law, this is as its name implies, their names is even defining them. Meaning the power in this case will be negative. The power here was 0, the power here is multiple, more than 1. So negative index law is when the power is negative. What do we do? What if we have x raised power minus n? What do we do? What do we do? This law states that let me prove it, then our final answer will be no. Okay, now 0 minus anything makes up a negative of that same number. That is 0 minus Peter is equal to minus Peter. That's the point. So 0 minus a positive integer will always give us minus that same positive integer. So that's the point. So 0 minus any positive integer is also equal to the negative of that positive integer. So for instance, 0 minus every integers are plus 1, plus 2, plus 3, like that. Now 0 minus any of this, I'll be having 0 minus 2 minus 2. You see, is a negative of this same positive integer. So that's the law. So provided we have this, that 0 minus any positive integer is equal to that same positive integer, we can apply by saying this is equal to 0 minus this same positive integer. So I can now say x raised by 0 divided by x raised by 1 n. I'm applying this law now. N minus n, 0 minus this, and I reversed it in this case. So I'm having x raised by 0 divided by x raised by n, which is equal n raised by 0, the fourth one, n raised by 0 is equal to 1. So 1 over x raised by n So therefore we cannot do that s raised to power minus n is equal to 1 over x raised to power n. That's the law for negative index. That's the law for negative index. So whenever you have, for instance, 2 raised to power minus 3 is actually equal to 1 over 2 raised to power 3 is equal to 1 over 8. So as simple as that. So that's that about this. Now the next one, okay, let me treat something. And that is, what if we now have ax raised to power minus n? What do we do? Just split it. You say this is equal to a times s raised to power minus n. Then you treat it differently. That is a times this one itself is equal to s raised to power n. So we are having a over s raised to power n equals to this. So that's just the point. So if you are given 2, okay, let me say 2a raised to power minus 1, it is actually equal to 2 times a raised to power minus 1, which is equal to 2 times 1 over a, so is equal to 2 over 8. That's the answer. So that's it. Except if they are being combined with this, that's when you can treat them together to be, okay, let me just use this again. Okay, let me just say now, okay, which is equal to 2 over a. So what if I now have it like this, 2a minus 1. So since the bracket has bring them together, then we treat them together also. So I say 2 raised power, okay, I'm still coming there, okay, 2 raised power minus 1. They know they both are entitled to this power now. So times a raised power minus 1. So you can say 1 over 2 times 1 over a, which is equal to 1 over 2a. Do you get the point? So these brackets made the both of them entitled to this. But since there's no brackets, only this is entitled to it. This is not part. So that's just that about that. So we've treated law 1 to law 5. Okay. I think we still have a long way to go. Still have a long way to go. Okay, now the sixth one. The sixth one is fractional index law. Now the name of this is also defining it. That is, the power in this case will be fraction. So if we are having a raised to power 1 over n, this is the fraction. So what do we do? This thing here is very simple. Yes, it is what is very simple. The point is the denominator becomes the root. The denominator becomes what? The root. So as if the denominator becomes the root, that is, if I'm having, okay, why do you know if I have this 1 over n, if I should multiply it by n, what happens? It is equal to a, isn't it? Because n will cancel n after multiplying it, isn't it? Why do you think it's equal to a? It is because, and okay, let's now say, why do you now think square root of s squared root is equal to s? Why does this cancel this? It is simply explained that this root, okay, let's now assume root x, let's treat it differently. Let's keep this thing as this n. It simply means this root here is equal to s raised to power 1 over the square root also over 2. So that's the reason why this can cut the root. So the reason why a square, the power of 2 can cut a square root is because they are equal. So a cube root can also a cube can also cut a cube root. A fourth power can also cut a fourth root power. A fourth root rather. So that's the same thing we are saying here in in short. So that's something. This thing here is equal to nth root a, all raised by 1. That's the point. Because this one remains there 1. So it simply means if I should have my base raised to power the denominator all over the numerator, therefore it is equal to the numerator, the root of the numerator, then I have the base within, guys. Now everything here is raised to power the So what am I saying? The denominator here, the numerator here. So here I have the denominator raised to power the what? The numerator. So same thing applies. Okay, so that simply means, like the example I will still use again is this: x raised by 1 over 2 is as well equal to square root of x. So x raised by 1 over 3 is equal to cube root of x. They are raised by 1, so it does not refer, since x raised by 1 is still that same thing. So that's the point. So okay, what if we are now given a raised by m over n? You apply the same thing. The denominator is the root, right? A always raised by the numerator, which is m. So if we are given x raised by 2 over 3, it is equal to cube root. Cube root what? X, everything all squared. So that's just that about the fractional index law. Now, these are the basic laws we are taught in mathematics for indices. But let me go for that now. The seventh one, what we now have, okay, let me say, okay, I don't give it a name. What we now have, ab raised power n. How do we solve this? Like I said here, once there is bracket, then everything in the brackets are entitled to the power. Now the point, provided they are binded with a multiplication sign. So you can now have a raised by n times b raised by n, which is equal to a raised by n, b raised by n. Same thing applies for the division. A over b all raised by n. Same thing, a raised by n over b raised by n. So that's that. Even the root also applies like that. So what if we are not given root? Okay, though this is understood actually, ab is equal to root, when they are combined with a multiplication sign, a times root b. Same thing for division, a over b is also like that, it's a over root b. So that's that about this. I hope it is clear. Okay, so let's move on. Let's step on to the next thing. Okay. Okay, what if we are now given a over b raised by minus n, so negative power? This thing here is actually, if we apply that negative index law, it is equal to 1 over everything we have, right? A over b raised by n, isn't it? So let me split it by saying it is equal to 1 divided by a raised by n over b raised by n. I've applied this now. So it is equal to 1 times b raised by n. You know the inverse now. So equals to b raised by n over a raised by n, which is equal to b over a raised by n. So what I'm just saying in short is that whenever you have any fraction raised to a negative power, just invert this raised to the same positive, to the positive integer of the same power. So b over a, I inverted this raised by the positive of this. That's just it. So that's what this is simply explaining. So whenever you have a fraction raised to a negative power, what you just do is very simple, extremely simple. You invert this, then raise to the positive of the same power. That's just it. So that's just what you do in that case. That's just what you do in that case. So, okay, another law is this, equal B's law. Equal B's law. As name implies, they are equal bases. So, but in this case, it is in form of, how about it? It works in an exponential equation. When an equal to sign, when it is an equation. You know, an equation is an equation because of the equal to sign in the involved, right? So if I'm having x raised by m equals to same base, don't forget, we have same base. What happens? M becomes equals to n because they cancel out each other. Now same thing, equal power. What if we now have equal power law or equal index law? Same thing, x raised by m equals to y raised to power m. They will cancel each other, so therefore x equals to y. So that's about the equal base and the equal power on this. So then for the last but not the least, now this is rare, and this is rare in our textbooks, and we don't even know it exists actually. So when you saw it, you feel like, oh, so I will be giving it here. So I would like you to be very attentive, and that is all called I will connect with it. Okay, which is last 11, right? Okay. What if we are given a question like this? X, Y, Z raised to power 4. What do you mean by X, Y, Z? For instance, assuming I have 8 root 16. I'm given this kind of question. Now, I don't have a calculator and I have to solve this. How do I go? I can split this into the, I can easily do square roots from, from my head probably. So how I can split this by coming with the multiplication. So I can therefore say, okay, 2, I can say, okay, let me say 2 times 2 times 2. It is still equal to this, isn't it? So this law now says this thing here is actually equals to x root y root z root then my base within. That's the law. That's the law. That's just the law. So let me apply using a true question now. So I have this kind of question. So let me now apply by saying, okay, this thing here is equal to square root, and that square, since there are 3, so it will be 3 square root, then my 16 within. So I'll do it one after the other. So we're having square root, then square root. Square root of 16 is what? 4. Okay, so let's move on again. Let me do this one within here. Square root of 4 here is 2. I'm left with 1. Now square root of 2 is equal to 1.414. I've just solved this without this, and if you do this directly, you still get the same thing. So that's just the last law. That's it about that. So thank you for staying to the end of the video, and don't forget to subscribe to this channel. So now let's start treating logarithm. That's the laws of logarithm. When you stand out to the laws and their applications, how to use them. So thank you once again. Don't forget to subscribe to this channel, just the Fikemans. Like and share, and anything you feel like, if you make there's an addition or subtraction, you can comment it below. And thanks for watching. Meet in our next class on logarithm. Thank you very much.